Okay, good evening everyone. I am Clelia from LlamaIndex. You might know LlamaIndex as a open source AI framework. That's our roots, that's how we started. Right now we're focusing on agents, and specifically agents that process documents and document data. So you can imagine PDFs, Word documents, and presentations, whatever unstructured documents you can think of, we process. So this might be a little bit of a different angle from from the one you know LlamaIndex from, but basically that's what we're doing now. So at LlamaIndex, just as a very quick introduction, I am an open source engineer. I also work on product, not right now, most of my time work on product and our cloud platform. We'll have time to mention that during the talk. So today's topic is the anatomy of an AI agent, with a focus specifically, as I was saying, on document agents, because that's what we're doing at LlamaIndex. And as an introductory note, you can find the presentation there. Like at the QR code, you can open and follow along the presentation. Otherwise, the link will be available, as Alfred was saying, next week. So, without further ado, let's get into it. So, agents, as you might have noticed, especially since last July, last August, are literally everywhere. We saw in 2025 that moving from just being tools that a specific part of the software development industry was using to speed up, their coding and stuff, to something that permeates our life. Just before, someone was talking about content management system and whatever, like every profession right now is using AI agents, and for the foreseeable future we'll use AI agents to improve and perform better. So some names out there like Manus, Claude Code, Gemini, ChatGPT agents, they're all building this I would say layer of automation that we're going to be exploring today. Obviously, agentic workflows right now, as I was saying, are the rule and not the exception, and they can do a lot of things for us. They browse, they write code, they do tasks on their own, they send messages, and whatever you can imagine potentially that doesn't involve a body, like a physical body, an agent can do. So the question is, what makes an agent a good agent? Because there are agents that can do things and that succeed at doing things and carrying on their own tasks, and there are agents that fail miserably at those tasks. What is the difference between the two? So the differences are on the harness, what we've been calling the harness for quite a while now. So basically how it thinks and acts, how it interacts with the word, so the tools that it has to interact with the word, how it controls its flow. So what are the steps, what are the checkpoints that the agent has, and how to give the right context. So what are the files the agent has access to, what are the information in general the agent has access to. So in this sense, we're going to explore an agent going through each of these parts as if it were a body, like a human body. So we're going to have an anatomical exploration of an agent, starting from the brain of an agent. So the brain of an agent is the LLM, so a large language model that acts as a foundation, as the main actor of an agent, like the underlying layer. Whatever interaction you have with an agent is mediated by the LLM. So, and decided by the LLM. So it produces thoughts, observations, actions, and it bases itself off of the context. The chat history, for example, the information it retrieves from files, from vector databases, from from whatever data source you give to the agent. And based on this context, the LLM decides what is next. Obviously, I will be anthropomorphizing LLMs a little bit in this talk. We know that LLMs don't decide, they just predict. But you will excuse this like non-technicality here and like anthropomorphizing a little bit LLMs. So the main problems that we have with LLMs, and as you are probably all aware, is that they are non-deterministic. So given the same input twice, the LLM will not produce the same output. So it's not like a computation, it's not like a script. So you input 1 and it gets 2 every time you input 1. It's non-deterministic. So how do we control and constrain something that is non-deterministic to act as we want? Well, my answer has been for a very long time JSON schema outputs. So controlled structured outputs. And we're going to dive a little deeper here in this. So we don't have, in a good agent, we don't have a way for the agent to escape the task it is given, to escape the thought. Like the agent cannot like produce an output that is not a thought, that is not an action, that is not an observation when it is constrained to do so, like the LLM in this case, when it is constrained to do so by the output schema. Of course, if you're using like small language models, that might break, because small language models are not very good. But with big vendors like OpenAI, Claude, like Anthropic, Gemini, it almost never breaks. So you don't have to worry about the agent not producing the output you want. So you have to find the right output to steer the LLM. So in this architecture, we are clearly separating the reasoning part, the action part, and the observation part based on this like structured output. So we force the LLM to take different steps, and for each steps generate a specific structured output that we can control. So we, as the developers of an agent, control this output, and as the user of an agent, you know what to expect. And you know that if something breaks during thinking is only related to one step, one specific output, so you go and look there. Okay, so that's the base. So the agent wrapper, basically the LLM wrapper that we have in this architecture, only exposes these methods, these like structure generation methods. There's no escape from there. There's no like free form, as I was saying. So like the typical interaction you have in ChatGPT, there's no free form. You have only structured outputs, and that's the only way you can reliably control the LLM's output. You can reliably constrain, more than control, the LLM outputs. And as I was saying, we have 4 operations, I would say 4 checkpoints, 4 steps that we use for control flow. We have thinking, acting, which means calling tools, observing, which means I call the tool, what happened after I call the tool, what is the state of my task right now. And once I observed, I can both decide to either go back and think about the next move, or stop and just like say, user, I completed task A, let's go and like give me another task, but basically this is complete. And this is based on these 4 steps, which we will see later how the steps should be implemented and could be implemented to make a good agent harness. But basically, these 4 steps are all constrained by the structured outputs that each step is assigned to. Obviously, this doesn't do anything on its own. We need to have a task execution layer. You know, the control flow I was mentioning before, the idea of how the agent runs. And in order to scaffold the agent, we use one building block, the first building block that at LlamaIndex we offer, which is called LlamaIndex agent workflows, which are, or Llama agents, if you prefer like shorter names, Llama agents, which are event-driven, async first, stepwise, an event-driven, async first, stepwise execution engine. That is a lot of words, but basically, as you can see them as I would say workflow or something that step by step executes a task. And you define the step in code, Python in this case, you define the step in code, and each step is guarded, is type guarded, is type safe, and is dispatched, and dispatches itself an event. So it's dispatched by and dispatches an event. So you can control the whole workflow by, you know, dispatching an event, receiving an event, dispatching an event from the start to the end. And you have a specific, you know, directional cyclic graph or directional acyclic graph depending on how you design it. But we support both cycles and like direct execution and, you know, branching out, fan in, fan out patterns. So we do have a lot of stuff. But for what concerns our agent here, as I was saying, we need a loop. We need a task execution loop that allows us to go from thinking to acting to observing and back to thinking if the task is not completed, or to the stop. So we have a branching and a loop. And that is basically how simple an agent can be. You know, an LLM that calls itself in a loop. But the loop here is controlled and constrained by type safe events and type specified, I would say, structured outputs, which are not precisely type safe depending on how you define them, but potentially I would say type safe. So everything here is controlled. It's like knowing what the LLM will do next, knowing what next step the LLM would take, and that is what makes basically the backbone of our agent, the task execution loop. And as I was saying, so you just like go to this agent, go to this workflow, you know, give it an input. The agent will think about the input and say, based on like the tools I have, we will be seeing the tools in a second, based on the tools I have, what can I do? Like what tool should I call? Should I just reply with text without like any tool calling? Should I just like not do anything at all? And based on the thought, it produces an action. The action can either be I stop because there's nothing more to do and I give a final response to the answer, or I observe, like I call a tool, I produce an action, and I observe what are the results of the tool. I call a multiplication tool, I call 3 times 5, the result is 15, I observe that the result is 15, what do I do from here? And obviously you can go back to thinking at that point and saying, okay, which will be the next step, which will be the next action. This is basically what the task execution, what the executor loop does in this architecture. There's nothing more complex. There's nothing, like I would say, nothing complicated. It's literally like a line, and you get back at a point, and you just decide at a point if you want to circle back or finish. Nothing more. Obviously, the agent itself, in its sandbox, in my terminal, in whatever application you put it, doesn't do anything. Okay, if I ask ChatGPT to go and, you know, search the web, if I didn't activate web search, ChatGPT cannot search the web. So we need to give windows on the word. We need to give like limbs, eyes, a mouth to these agents to be able to interact with you. Okay, so in order to like basically produce these windows on the word, we can, like, in order to understand these windows on the word, we can break them down in 3 macro categories. File system, which means basically the files that are on your computer, the directories that are on your computer, so those things that the agent can read, modify potentially, and write or delete. The tools, which are everything else, so the web search, whatever. In this case, we have document tools. So if you are reading my documents, you know, you cannot read a PDF, like an agent cannot read a PDF. You can, as a human, because you see the text, but the agent doesn't see the text. It just sees a lot of like garbage, binary data. So you have to convert the PDF to readable text, machine readable text. So how do you do that? We equip the agent with yet another LlamaIndex product, LlamaParse, which parses the PDF into machine readable text, markdown or text or like plain text, and the agent can just like read that. we can classify a document. So the agent isn't sure whether to read or not a document, because the user said only read contracts. Okay, only read the contracts in this directory. So the agent has to classify the document first. It doesn't want to read something that is not a contract. So we classify whether this is a contract, an invoice, or whatever else. And then the agent, once the agent has classified the document, it can parse it and read it. Or like basically can extract structured data. Once it read the document, it can like extract structured data, kind of like JSON outputs. Both these tools are also provided by LlamaIndex with the Llama Classify and LlamaExtract service. So you basically have this kind of like tools that the agent can use to manipulate the document. So interact with the file system directly, manipulating documents. But obviously this doesn't do anything if there's no way to interface with the agent. So we use a chat interface. Chat interface in this case is a Telegram bot. So you can use it as a Telegram bot, like OpenCloud or Claude bot or whatever it is called now. This is basically chat interface that allows you to interact with the agent. But since the agent is kind of long running, because it takes time to parse a document, especially if it has a lot of pages, it takes time to classify a document. So what you do is just send a message, and then Telegram pushes the notification. It has push notifications, when the agent is done, and that's produced a response. It's kind of like, I would say, a coworker more than just like a spinner tool that you see on ChatGPT or whatever agent tool platform you go. So let's start with the file system, or better, virtual file system, which are the eyes that the agent uses to see, the context in which it is moved. We are using something called virtual file system in this case, because we don't want the agent to mess up with our file system, with our real machine file system. So we use agentfs, which is an SQLite-based file system that does a lot of stuff, very similar to Unix. And so you can do all the operations that you can do on a normal file system. You can basically replicate them on agentfs. So you can read, modify, write files, and also delete them. Our agent can only do read, write, and modify. And that is only because we ask. And it can only do it on your file system. So even if it is, I would say, convinced to write a malicious script, it wouldn't be able to execute it because it's not on your real file system. It's in agentfs, which is basically just a database that stores binary data. We don't have, I would say, full FS access, full file system access, because that's obviously a little bit, I would say, dangerous. But we do have, as I was saying, limited read, write, and edit access that the agent can use to gather context, or, for example, get a file from the file system, from the virtual file system, parse it, store the result in the virtual file system, and have basically a persistent reference of the parsing result from a tool. So you basically have virtual file system that guards you from nuking your own. Let's put it like that, from corrupting your own file system, which is extremely bad. So if someone has access to your file system on your machine, you're pretty screwed, because basically you have all the files you have on your machine. So this is one layer, I would say, of security. We'll talk about it more later. But this is the eyes of the agent. So the agent can see, read, edit, modify the documents through this virtual file system. Obviously, as I was saying, we have the limbs, the tools. Parsing documents, classifying a document, extracting structured data from a document. They're all like things that we humans can do very, very well, because we can read presentation PDFs because they are displayed on the computer, like they're rendered on the computer by software that knows how to render the byte data of the presentation or the PDF to us, like human readable. But the machine can't. So we have to first parse or like classify or extract data from these files with specialized tools. And at LlamaIndex we offer, as I was saying, this like kind of agentic tools and OCR tools that are able to recognize the text from a document, extract it, and give it back to the agent as a complete context. You don't want to use PDF to text because it scrambles the layout. It doesn't extract images. Whereas this kind of tools allow the agent to unblock, the next level of contextual understanding of your files. So if you are working in a directory full of PDFs, PDF to text or the basic PDF tool that Claude Code offers you is not going to unblock that kind of like next layer of thing. Like Claude Code is going to have a superficial understanding of the text and like how it is disposed, but it is most likely to misunderstand things, because PDF to text tends to like clump everything together and screw up the layout and like lose information about tables, whereas these kind of tools are able to preserve tables, preserve charts, preserve images that the agent can then take a look at, can then go and see. So this is basically why you need these kind of tools in your agent. You want the agent to have access to this kind of document knowledge to help you better understand this kind of like documents. Last but not least, as I was saying, the chat interface, the ears and mouth of your agent. So basically, with this chat interface, like in this case, you can upload PDFs, text documents, Word documents through Telegram. These are the only documents that Telegram basically allows to upload. And then you can just parse them. You can just like save them to your virtual file system of where your agent is running, and you parse them. You read them, whatever the agent wants to do. The agent does whatever it wants to do. And the key fact here, as I was saying before, is that this kind of like interaction is asynchronous. When you send a message to Telegram or WhatsApp or Discord to a friend, you don't expect them to, reply immediately. That's what the agent does. The agent takes its time to process the file, to call the tools, to go through that decision loop, to the task execution loop that we saw before, and then it, gets to a conclusion and it sends it back to you. So it pushes the notification, Telegram pushes a notification, and you go, oh, hey, the agent is done. My task is complete. That's basically how OpenClaw works and how other stuff works. Obviously, probably a great difference in the agent harness here, but this is how you want to build your agent. And unless obviously you want like low latency chat, kind of low latency chat like ChatGPT, but if you want an agent that is able to do autonomous work, you have to have this agent asynchronous. Like you have to have this agent like do asynchronous work on its own and then get back to you. Obviously this comes with security and safety concerns. That's why we have to do a note on safety for this architecture. First, we only use virtual file system, and we've already been through this. Second, we don't give the agent shell execution, because if I gave the agent my bash console, the agent can still nuke my file system, whatever it wants, can still execute rm-rf on the root folder and like destroy my file system. So we don't want that. So no shell execution, virtual file system. We don't want the agent to perform destructive operations, so we don't give the agent access to deleting files, because we don't want to lose data because the agent misunderstood the assignment and just deleted the entire folder. Okay, happened to me once, wasn't very good. So, and then we have probably the most controversial thing. We don't allow for skill execution, so we don't inject with external context. Skill execution is basically prompt context injection in the current context window of the model, and the model gets the context from the skill. That's a kind of problem if the skill is not vetted, if the skill is not audited. If you don't know what the skill contains, it can have hidden malicious instruction for your agent to execute, and basically your agent can leak your own data and whatever, can just like give the data to the person that wrote the skill. Obviously most skills are not like that, but we don't want to have that in an asynchronous autonomous agent setup. We don't want to have the risk of the agent just executing a skill unsupervised and that skill being malicious. So we avoid that part. Obviously, the agent, being the agent, like, you interact with the agent as a user, the agent is still subject to, prompt injection, jailbreaks, other malicious prompt attacks, the whole surface of natural language attacks that the LLMs are susceptible to. So you might want also to implement guardrails there between when the user submits a request and when the agent receives a request, and the guardrail would basically, bump the request back if deemed, prompt injection or generally unsafe. So this is the full anatomy. We went full circle. We saw the brain, the LLM, the eyes, file system. limbs, our tools, and the ears and mouth, the basically chat interface, so the way the agent interfaces with us. We have a few key takeaways I would like you to take home from this presentation. So if you have to remember something from this presentation, is that structured outputs are vital if you're building agents, because you can control structured outputs. You cannot control, as much as you can try, you cannot control the agent output with regex matching, with like any kind of text analysis. If you want control over the output of your LLM, use structured outputs, JSON structured outputs, or Tune, or whatever structured output, or YAML, whatever structured outputs are offered by your provider. Event-driven loops and execution task executor are vital, because you know the gist of it. You know what goes in, you know the steps, you know what goes out. You define the schema for each event, and you know which steps dispatches event A, which steps receives event A, what the steps produce, and you basically know the whole shebang, the whole process of going from input to output. Virtual file system is extremely important as well, because to avoid damaging your own, you use something that is virtualized, that the agent cannot really damage. And even if it damages it, you just lost a SQL-like database. You didn't really lose anything. Your file system is intact, no problem with that. Async chat interfaces are probably the future of autonomous agents, and you probably want to build your agents based on that. When you let Claude Code run in the background, when you let OpenClaw run in the background of your Telegram interface, you want to build interfaces that are for that, not for immediate interaction. Because obviously something that requires your immediate attention doesn't multiply your productivity, it hinders you. So if I get ChatGPT to constantly ask me, what should I do next? What should I do next? It hinders you. So you have to have something that is autonomous, but is constrained by the guardrails that we discussed before, so that you don't damage your file system, leak your data, or whatever, okay? And you have to have, powerful tools and things like that, but that are not dangerous, unsafe, that don't give the agent too much power. So if you want to build your agent, build it autonomous, build it asynchronous, but build it safe. That's all. You can find the GitHub repository at the link I had before, and you can find me like on LinkedIn, X. I have my personal website, and you can also email me at Clelia@runllama.ai. That's pretty much it for my talk, and hope I didn't get it too long.